More interstellar comets are inbound for Earth, so get ready for more. This is what astronomers are warning us. We'll read today's article from Yale University on phys.org. We've already had one in 2017, the Huma interstellar comet. That shocked everybody. Where was it coming from? They saw it on its way out and found it a few hours beforehand. This time, another one has been found the beginning of August by an amateur astronomer of all people, not even space agencies, amateur astronomer. And he found it because he was watching the sun. I guess it's because a lot of people have been watching the sun because they feel that there have been sightings there of various objects that are around the sun, like some people saying Planet X, Nibiru, Wormwood, Nemesis, take your pick, various names for whatever it could be there. And he saw it, and he reported it, and the space agencies confirmed it was an interstellar comet coming in at us. Interstellar, it's not from our solar system. Why are there so many interstellar objects coming into Earth all of a sudden? And it's now visible by amateur telescopes if you point them towards Mars. It's passing us now, and it'll be here until October. It's going outbound until December, I believe. Between Mars and Earth. It's found between us and Mars. So get ready for more interstellar objects, astronomers are saying. This is by Jim Shelton of Yale University on phys.org. Gregory Lawlin and Melina Rice were not exactly surprised a few weeks ago when they learned that a second interstellar object made its way into our solar system. As we said, it was found by an amateur astronomer from Crimea called Borisov. That's why they call it the Borisov comet, interstellar object. The Yale University astronomers had just put the finishing touches on a new study suggesting that these strange icy visitors from other planets are going to keep coming right in. We can expect a few large objects showing up every year, they say, every year. Smaller objects entering our solar system could reach into the hundreds every year. And my question is, what's out there so close to us that's spitting out these objects coming in at us? They're not even in our solar system. Well, maybe we shouldn't be surprised, because a few years ago, NASA had a lady announce to us that we have a brown dwarf star at the edge of our solar system. A brown dwarf star at the edge of our solar system. That's bad news. Now, if it's a brown dwarf star, maybe it has some planets around with it. Stars usually have planets. A planetary system, a solar system with planets. Now, the study has been accepted for publication in the astrophysical journal Letters. Quote, "There should be a lot of this material floating around," end quote, said Rice, a graduate student at Yale and first author of the study. Rice says so much more data will be coming out soon thanks to new telescopes coming online. We won't have to speculate. The first interstellar object known to pass through our solar system was Huma, as we remember, that was spotted October 2017. Its arrival generated intense debate over its origins and how to classify it. Lawlin, an astronomy professor at Yale, contributed valuable research indicating Huma likely has properties similar to a comet, despite the fact it did not have a comet's tail or a coma. The new object does have a tail. It's recently dubbed 21 Borisov because it came on the scene this summer. Amateur astronomer, he said, Gennady Borisov of Crimea Russia first noticed 21 Borisov in early August, and researchers will have about a year to observe the object with telescopes, a considerably long time than a few weeks that they had to observe Huma as it was leaving us. Now, the new object is also larger than Huma and has a pronounced tail. Of course, for scientists, it's one of the big questions arising from the appearance of this interstellar comet. The question is, where did they come from? Why are they all of a sudden inbound to us? What's out there so close to us that is spitting out these objects coming in at us? An easy answer would be that they are ejected planetary building blocks. Ejected planetary building blocks. That's bad news. Planetesimals from other solar systems. Well, yeah, no kidding. And what's another solar system doing? Well, we've already been told. We have a brown dwarf star. I shouldn't laugh. They had a lady come out to announce it. You know why? Because we had to feel sorry for her. She's a lady. So in our mind, you can't, if it was a man, you'd somehow, but if it's a lady, she was very reserved and very careful about delivering this bad news to us. So we were told a couple of years back that we have a brown dwarf star at the end of the solar system. Of course, a star has a solar system around it, a sun system. Now, what is it there? Why would they all of a sudden be around there? Now, upon their first look, there's a problem with that theory, says researchers. A close study of the roughly 4,000 confirmed planets outside of our solar system, 4,000 planets outside of our solar system, shows that most of them are located too close to their parent stars to readily eject planetesimal matter. Planetesimals stirred up by most currently known planets would remain stuck in orbit in the systems that they are formed in. Rice and Lawley's work proposes for the first time that interstellar objects could be material ejected from larger, newborn planets orbiting farther away from their sun, which have carved out pronounced gaps in the cosmic platters of gas and dust that astronomers call protoplanetary disks. When a star is newly formed, it's surrounded by thin, rotating protoplanetary disks of dense gas and dust. The disk is a volatile environment in which gas and dust are heated up by the young star, as well as the star's gravitational energy, leading to movements, collisions, and eventually the formation of planets. Although most planets come close to their sun, there are some that develop much farther away and create large gaps in the protoplanetary disk, and according to Rice and Lawley, those more distant planets are able to fling out material that could leave their home solar systems. But they're also much more difficult to directly observe than their closer in counterparts, which is why not many of these planets have been found. To test their theory, the researchers looked at 3 protoplanetary disks from the disk substructures at High Angular Resolution Project, DSHARP for short, a survey conducted by a large consortium of astronomers. DSHARP focuses on images of 20 nearby, bright and large, protoplanetary disks taken by the Atacama large millimeter, submillimeter array telescope in Chile. Quote, "We were looking for disks in which it was pretty clear a planet was there," Rice said. "If a disk has clear gaps in it, like several of the DSHARP disks do, it's possible to extrapolate what type of planet would be there. Then we can simulate the systems to see how much material should be ejected over time. The idea nicely explains the high density of these objects drifting in interstellar space, and it shows that we should be finding up to hundreds of these objects with upcoming surveys coming online next year," Lawlin said. "Beyond the more novelty of noticing interstellar objects passing through our solar system, which is shocking to me, because, you can't ever tell their orbit. At least the things we have in our solar system, we know their orbit, and they're on the same plane with us. They're not coming in, smacking into everything in our solar system like a billiard ball. Then everything would be out of whack. God forbid. God forbid. Now, beyond the more novelty of noticing interstellar objects passing through our solar system, the idea of observing such objects offers major possibilities for advancing our knowledge of the cosmos. No kidding. We're advancing the knowledge of our cosmos. Who cares? Who cares? What you care about is to get these things away from us and away from our solar system, because if they smack into any of our planets or celestial bodies around us, there are any moons, they're going to be throwing them any which way, like a billiard ball on a billiard table. That's chaos. Chaos. Unlike many astronomical discoveries in which data is observed and interpreted from tremendous distances, interstellar objects are an up-close look at another part of the galaxy, they said. They said, you're not looking at a distant star through a telescope, Rice said. It is actually material that makes up planets and other solar systems being flung at us. It's being flung at us. I'm quoting what she says there. It's a completely unprecedented way to study extrasolar systems up close, and this field is going to start exploding with data very soon. No kidding. This is ridiculous. I mean, this is really serious. I think, you guys, this is really, really serious. Really serious stuff. And this is just today's article. This is serious stuff. We should all get telescopes and become amateur astronomers, really. There's not enough people looking at the skies to see what's out there. Okay, I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.